This is 2.4, solving multistep inequalities. To solve a multistep inequality, simplify each side of the inequality if necessary, then use inverse operations to isolate the variable. Remember that inverse operations are opposite operations, and so addition and subtraction will undo each other, and multiplication and division will undo each other. We cannot mix and match addition with division, subtraction with multiplication. They must be each with their own here. And one last thing, remember that if you multiply or divide by a negative number, you need to reverse the sign. So the inequality symbol will switch directions. If we are going to solve and graph, 3x minus 2 is less than 4. To get x by itself, we are going to add 2 to each side. To get 3x is less than 6. Then to undo this multiplication, we are going to divide each side by 3. That leaves x is less than 2. So in my graph, 2 is going to have an open circle, and it is going to point to the left. For x over negative 5 plus 4 is greater than or equal to 3, we would add 4 to each side, which leaves x over negative 5 is greater than or equal to negative 1. Then to undo this division, we need to multiply each side by negative 5, and so x is less than or equal to 5. Since we multiplied by a negative number, we had to switch the direction. And my graph will have a closed circle and point to the left. For 3/4 y plus 1 is less than or equal to negative 2, I'm going to subtract 1 on each side, which leaves 3/4 y is less than or equal to negative 3. Then to divide by this fraction, we need to multiply by the reciprocal. So that gives y is less than or equal to negative 12 over 3. When negative 12 divided by 3 is negative 4. Graphing that, it has a closed circle and points to the left. Now we have 12 is greater than negative x over 8 plus 2. I'm going to subtract 2 on each side, and 10 is greater than negative x over 8. I'm going to multiply each side by negative 8. My inequality symbol reverses to get negative 80 is less than x. This will have an open circle and point to the right. And here we have 2x plus 3 is greater than or equal to 5x minus 1. I'm going to put all variable terms on the same side by subtracting 2x. And 3 is greater than or equal to 3x minus 1. Add 1 to each side to isolate this variable term, and we get 4 is greater than or equal to 3x. Then divide each side by 3. And we're going to leave our answer as the improper fraction of 4/3 is greater than or equal to x. We do not rewrite as a mixed number, and don't change it to a decimal unless you are told to. Improper fractions in their simplest form are fine. Alright, we have a couple more. So 15x plus 2 is greater than or equal to 3 times 5x minus 1. I'm going to start by distributing this 3 to each term inside the parentheses, and I get 15x plus 2 is greater than 15x minus 3. Put all constant terms on the same side, so we add 3. 15x plus 5 is greater than 15x. Subtract 15x on each side to put all variable terms on the same side. And I get 5 is greater than 0. 5 is always greater than 0. I also don't have any x's left. X can be anything in this case. So my answer is all real numbers. And for this last one, we have 8b minus 3 is greater than 4 times 2b plus 3. Again, starting with distributing, I get 8b minus 3 is greater than 8b plus 12. Add 3 to each side, and we get 8b is greater than 8b plus 15. You might be thinking already, that doesn't make sense. How can 8b be greater than 8b adding more onto it? But anyway, we're going to put all variable terms on the same side, and we get 0 is greater than 15. 0 is not greater than 15. This is not true, and so our answer is no solution.